All right, let's get started. Please download Laboratory 17 from Blackboard. And today we are going to learn how to do the simulations and how to calculate probabilities. First, please run the first cell to identify host name, username, and current information. And please input your name, your R number, and title and the date. All right. The first one is about how to simulate some games or some situations. The first example is about the Russian roulette. So Russian roulette is a little game of chance in which a player plays a single round in a revolver. So it's a dangerous game, right?
We're basically doing what we.
So here we will learn how to simulate this game of Russian roulette for 2 rounds, 5 rounds, and 10 rounds. All right. So first, you need to import NumPy as NP, right? You need to import NumPy package, and after that, please make sure to create a NumPy array. In this array, we have only one and 5 zeros. It means they are this 1 means it's a bullet, and 5 means the 5 empty chambers. Right, so it is a NumPy array, and after that you can use a random choice function, and here is the array name and how many times you want to select. Okay, it will randomly select a value from this revolver. It's just a simulation, right? Right, and see there 0 0 is a simulation, and the next time for 5 rounds. So see 0 means the empty, 1 means the bullet, right? And the 10 means 0 1 0 0 0, right? So it's about how to simulate this one with a NumPy array and with a random choice function. Okay. So any questions so far? Okay. And next one is like a classic problem. It's called a Monty Hall problem. It's on a TV show, right? Suppose you are on a game show and you are given the choice of 3 doors. Behind one door is a car, behind the others, goats. You pick a door, say number 1, and the host, who knows what's behind the doors, opens another door, say number 3, which has a goat. He then says to you, do you want to pick door number 2? Yes or no? And is it to your advantage to switch your choice? So it's a classic question, right? I think perhaps you have already heard this problem from maybe other subjects, maybe from mathematics courses, right? So the answer should be yes. You should switch your choice, and it is to your advantage to switch your choice. But here we don't do the calculations. In this class, we use Python code to simulate this problem and show you and simulate it like 1,000 times and show like the probability of your choice of switching your choice and remaining your choice. Okay, so this diagram, there are 3 doors, and you choose one, say it's number 1, it's your initial choice, and then the host knows what is behind the other doors. Number 3, they are goals, right? So switch or not. Okay. So let's define some functions first. Simulate Monty Hall games for 1,000 times. So define a function and return another goat. First thing here, right? So define other goat. So if x is equal to 1, then return goat 2. If x is equal to 2, then return goat 1. So it's just a simple function. You can find it from the function name. It's other goat. It means you pass 1 goat, then return another goat for you. All right. And next one, we need to simulate the list for the objects behind the doors. We have 3 different objects, right? Car, goat 1, and goat 2, right? It is the doors. And then we set another list called goats. Goat 1 and goat 2 define, so we can define a list for this goats, right? And after that, we can simulate this game. So because you have 3 choices, right? So you can use numpy.random choice doors. So you can select car, go to 1 or go to 2, right? Because at first you don't have any other hints. You can only like randomly selected a door, right? So that's why here all the go to 1, go to 2, go to under the car, they both they all have the same probability. They are 1/3, right? So that's why here we have 3 different choices, and then we set the conditional statement. So if user guess would be go to 1, then return go to 1, return go to 1, and then go to 2 and car, right? And the second one would be number 3, because if you select go to 1, then the host will open another door which has a goat. So he can only open the door which has go to 2. So the remaining car has the car, or remaining door has the car, right? And the second one, if you choose go to, then the host will reveal the go to 1 for you, and then the remaining door has the car. Okay, and if you have already choose the car, then this reviewed by the host will be randomly selected, go to 1 or go to. That's why we use these goats, right? Select randomly choice goat, so you can select go to 1 or go to, and after that you can use this function to show the other one, the other goat, right? So that's why we need to define this list for goats, and we need to define this function for another goat. Okay, it's about how to simulate the game. More efficient to use else if. Yes, actually, it's a good point. Yeah, actually, you can use the else if and then else. It would be more efficient. Yeah, but yeah, when I write the code, I forgot that. Yeah, very good. Yeah, you can use else if, and the last one would be else. Yeah, that's thank you. It's a good point. Yeah, here I can show you. Yeah, but it doesn't. So you can use else if, and then you can just use else, because there are only 3 choices, right? Okay, yeah, let's continue. Thank you. It's a good point. Next, let's check and see if the MH game is working, so we can simulate it for one time. As you see here, this NumPy range is it's the same as the range function for I range, but it's more efficient. So it's about how to write the algorithms of that. So you need to know, like, it's efficient. This one is more efficient, but it doesn't matter if you use this range, because for now your code is not like parallel processing, so it doesn't matter. Yeah, so after that you can use this. A is the MGH, so it will return this one, return the list, right? And after that, print the list and print each one of them. So it's only 1, right? You can run again. So it could be different because it's a simulation. So A is randomly selected, so it could be different. So your result would be different from mine, right? So go to 1, go to or car. And after that, we can simulate it for 1,000 times. So we create 3 lists. The first one would be user guess. The second one would be the reviewed. It can only be go to 1 or go to 2, right? Because the host will open this door for you, and then it only contains like a go to 1 or go to 2. All right. And after that, we create the last one for remaining list. Okay, so and in each round, use a for loop, and each round the first element would be the user guesses, and second one, the reviewed one would be the second one, and then the third one. Okay. And after that, you can use pandas because for now, these three lists can be the content of a data frame. So that's why here we can define a dictionary and make a data frame. After that, you can check the data frame, right? So there are 1,000 elements. So for the second column, it's only like there's only two kinds of contents, like go to one or go to. But for the first one, guess would be 3, and I think each of them is about 1/3. Like it's maybe 333 or 34, but it's may not, but because it's a simulation, it's not very accurate, right? And after that, you can get the count of each atoms in the first and the third column. So you can use this way to check the which row has the car, and then shape 0, because if you remember shape is the row, how many rows and how many columns, right? And shape 0 means the first element of the shape. It means how many rows. It means the count of the car, right, in the first column. And the second one is about the third column. It's the third column because the remaining one, right? And for other things, it's the same. So actually, you can print out. For instance, here, original can print. Then you see it's about 333. It's not exactly 333, right? But it's about roughly. Okay, so and after that, you need to draw a bar plot to show the results, right? Import matplotlib and set the width of the bar and set the height of the bar is a bar number, right? This takes these numbers, and you need to learn how to set the position of the bar of x-axis. You can learn to set it. Use R1 or R2, and plot the bar. And x-ticks means you can put the car and other things and go to 1 and go 2 in behind the bar, not beneath, under the bar, and show that. Let's check out. Okay, so it is a result. So you can check the orange one is the simulations for the initial user guess, right? Initial, and for the remaining door, you see it's like a 2/3. The probability of the remaining store had a car, which had a car, is 2/3. That's why you definitely need to switch your choice. Okay. Yeah. So in this way, we can use the simulation data to show that we need to switch our choice, and it's to our advantages to switch our choices. Okay. So it's very interesting, but it's not very accurate because it's just a simulation. So perhaps you will have a different result from mine, but I think the result will also show you need to switch the choice. This blue bar will much higher than the original one. Okay, so it's about the second example. So any questions so far? All right, next one is about the probability. It's let's see some terminologies. The first one is experiment. So occurrence of a certain outcome that we can observe. Outcome result of an experiment. And sample space, event, probability. So you have so outcome would be the result of an experiment. The sample space would be the set of all possible outcomes from the experiment. So probability is outcome divided by sample space. So, okay, so let's see concrete examples. First one, you need to import NumPy, pandas, matplotlib, I think in the following classes, you need to import these 3 packages in each lab, okay? And then let's go back to the first example in the game of Russian roulette. So chance of surviving each round is 5, 6, which is about 83%. So use a for loop to compute the probability of surviving. Okay, so for 2 rounds, 5 rounds, and 10 rounds. So in this one, you will see they are very, very similar. So they have the same patterns in the following examples. The first one, you need to have 2 lists. The first one is used to store the number of the rounds, and the second one is about the probabilities, and then use a for loop and append the number of the rounds, and the second one probability list append 5, 6 to the power of I. Okay, so it means the first for the first round it is 5, 5, 6, and for the sixth one is 5, 6 squared, right? And after that, you can use, because they are all lists, so you can use the list as the content of a data frame and set the column name. It is a dictionary, right? And set the column name and set the content of your data frame. And after that, show your data frame. All right. And next one is about the probability of surviving for the range. It's for 5 rounds, so it's similar, but the only difference is the arguments of the range function. So here is a 3 means from 0 to 2, and the second one would be 6 means from 0 to 5, 5th round, right? And here's 11 means the last one would be 10. It's very small, right? 16, only 16%. And actually, you can also plot the figure. You can use the rdf.plot.scatter. So in the last lab, we learned how to draw a scatter plot with data frame, right? So yeah, and please make sure you have the correct, you have the right column name, okay? Yeah, so it is about the first example of probability. So any questions so far? Okay, next one is about the probability constantly throwing an even number with a D20, 15 rows. So it means D20 means there are 20 possible outcomes from 1 to 20. And even number would be 1/2, right? Then you can use a similar pattern to list number of rows and the probabilities, and append that. And the next one to calculate the probability of each round and store it in a data frame and plot the scatter plot. Okay. So it's similar, right? And after that is at least 6. So it would be different because last one is throwing an even number, or this is surviving. But here is at least 1/6. So we need to compute the opposite situation. It means there's no 6. What is the probability of throwing no 6 with a D6? So here, no 6 means it will be the other 5 outcomes from 1 to 5, right? So that's why, and the probability of that is 5, 6. So here we need to calculate. So the other things is the same, but this one different. So we need to use the 5, 6 to the power of I and use 1 to minus 8. So this is used to calculate throwing no 6, and then it is at least 1/6. All right. It's a result for the 3 for two rows, 5 rows, 10 rows, and after that 50 rows, and the scatter plot. All right, so it's pretty clear. Scatter plot, okay. Next one is very similar. So drawing an ace at least once. So we need to compute the update of situation, it means drawing no aces. So no aces because standard card, there are 52 cards, and the aces, there are 4 cards. So the other things, the other cards, they have, the number would be 48. So it's a result. Okay. Right. It's a result. Okay, so any questions so far for the probabilities and how to simulate the probabilities? Okay, next one is about the last example. It's also about the important example. First thing, you need to write a function to find the probability of an event in percentage from a form based on the given outcomes and sample space. So first thing you need to define, can you call it a prob? And then 2 arguments, outcome and sample space. And probability, the result would be outcome divided by sample space and multiply 100. And then please use the round function. If you remember I'm not sure you remember the function of the round. So at the round, it means it will return probability rounded but to 1 decimal point, 1 decimal place. Okay, it will keep the first digits after the decimal point. So let's check out the concrete examples. The second one would be, here is probability of rolling a 4 with a d6. So 4 means the outcome would be 1 and space would be 6, and pass the arguments. It is 16.7%, right? So here we have only one digits after the decimal point. Here is around 1, okay? And next one here is drawing a king from a standard deck of cards. So outcome would be 4 because we have 4 king cards in the standard of deck of cards. And the sample space would be 52. The result would be 7.7, right? And the king of the hearts is only 152. It's 1.9, right? And after that is the drawing an ace after drawing a king. So drawing an ace is only 4 outcomes, but you have already drawn a king, so there's only 51 cards left. So it is about sample space is 51, right? So 51. And the last one, and the next one is about 1 as ace is already drawn. So it is ace after drawing an ace. So there's only 3 aces left and 51 cards left. So the result it would be 3 and 51. And here is the heart or club. So heart, there are 13 cards, clubs 13 cards, and outcome sample space would be 52. So you can plus them together. The result is 500. Even not 500. It's 50%, right? And last one, drawing a royal flush. Royal flush is first thing you actually there are 4 kinds of cards, right? The heart, clubs, or other 2 cans. So we will ignore that first. At last, we will multiply 4. Okay. So for instance, we want to draw a hearts royal flush. Then first thing we have 5 cards to choose, right? 5 cards, and the sample space will be 52. And the second one, we can choose 4 cards and 51 left. 3 cards, 50 left, 2 cards, 49 left. And after that, after you choose them 4 times, there's only 1 card can left can be used to build this royal flush. So only 1 and 48. Okay. And then there are 4 cans of a royal flush. So multiply 4. And then after that, choose the result. It's very, very small, right? So that's why here royal flush is a very it's almost impossible, right? So it's very, very small. It's about how to calculate the probability of an event, use your Python codes, okay? Yeah, so that's all the examples. And today we have 2 exercises. I think it's pretty hard. So I give you some hints here. I have already solved the first questions of each exercise. So you can follow my codes and answer the second question, okay? So the first one, so here we have 2 dice and thrown once, and the total score is observed. Define the function and use a simulation to calculate the probability. Total score is greater than 10. So first thing you need to simulate the dice, right? You can use this way, import NumPy and define this function, can dice row 1, and set the simulation number as the arguments, and set the dice, right? Set the dice d6 from 1 to 6, and then you can simulate like 2 dice because you need to use the total number, right? 2 dice, simulate two times, and then score them, plug them together to get the score. And if the score is greater than 10, then we'll add 1 to this count, and then after that, use the count divided by the simulations number to compute the probability. And then you can set different one. So at least 10,000, okay? So as a result, it would be about 8.26%, okay? So the second one, you need to compute it's even and greater than 7. So it means it's 8, 10, and 12, okay? So the result would be roughly 25%. So if your result would be much higher or much smaller than 25%, perhaps it's wrong. So please double check that, and please make sure you have like at least 10,000 simulations. Okay, so you can follow my codes and make some revision to answer the second question. Okay, it's about the first exercise. The second one is it's more complicated. So this one, in this exercise, we have like 10 white balls, 20 reds, and 30 greens. We want to draw 5 balls with replacement with a simulation to find the probability as we draw 3 white and 2 red balls. So here, because in the previous example, we use the NumPy.array to simulate the data, right? But in this one we have colors. They are not just numbers, right? So that's why here we need to use another way. We can use a dictionary to simulate it. So for instance, import NumPy and then set a dictionary, create a dictionary associated the numbers and the colors. So for instance, we can set total of 60 balls, and we can set the first 10 numbers. If I is smaller than 10, it means if I is 1 from 0 to 9, they are represent white balls. So we can use the dictionary. So I would be the key and white would be the value. So if I is from 0 to 9, then it is white. If I is from 10 to 29, then it is red. And if I is 20 from 30 to 59, it is green. Okay. And you can use this way to associate numbers and the colors. And after that, you can use your familiar way. You can use the randomly random int or randomly choice function to get a randomly selected number from 0 to 59, and then you can know it is a white or red balls, right? So here the second simulation. So 5 means you want to draw 5 balls, right? 5 balls and append this random int. It means some randomly selecting the number from 0 to 59, and after that, you can use this draw to get it. So if it is, for instance, if the first if the first number would be 6, and then you will know it is a white, right? Because here D6 is white because I is smaller than 10. And if it is 40, then you will know D40 would be green. And you can use this way to sum the numbers to count the different numbers of each balls, of the balls of each color. And after that, if the desired condition is met, then add 1 to the counter, outcome counter 1 and plus 1, and the result would be only 0.6%. So the next one would be, you can follow this code and make some revision and answer the second question. So the result is roughly 3.5%, I think. So if your result is much higher or much smaller, perhaps you need to double check your code, okay? Yeah, so it's about the 2 exercises today. If you have any other questions, you can send me an email, all right? So that's all I want to share today. If you don't have any other questions, please feel free to leave the meeting. Thank you guys, have a nice day, and see you on Wednesday. Okay, so if you have questions, you can stay here, we can have a discussion. No, it's not close. Because because I ask you to set the simulation time at least 10,000, so it cannot be 16%, I think. It could be maybe 24.1 or 26.1, but it cannot be 16, I think. Please double check your code, right? What all I is supposed to change? What I think you need to figure it by yourself. So what do you need to change in the code? I think there's no such big things you need to change. Maybe only smaller things, I think. Okay, I think might be screen or phone. It might be, let me try again. So 7 score. Yeah. So you see, I changed several times, so it's like 20, not 16, right? So okay, so please double check your code. Yeah, it cannot be so low. Okay, any other questions? Expected UF while parking mean. Actually, it's there are many possible reasons about that, but unexpected UF. So I think it's about like maybe perhaps you have some indentations, or you forgot to use some round brackets or some other things. Yeah, there are many possible reasons to cause this error. Okay, yeah, please double check that. Okay, so I stop here, and if you have any other questions, please send me an email. All right. Thank you, guys.